Good afternoon, bon après-midi. Welcome to this special edition of the Physical Society Colloquium, organized jointly with the Department of Physics Equity, Diversity, and Inclusion Committee. I'm coming to you live from the brutalist majesty of the Rutherford Physics Building at McGill University in beautiful downtown Montreal, where the problems are stumping and the bandwidth is high. If you are in the Zoom session and you prefer not to be recorded or live streamed, please log out of Zoom and join us via YouTube. This afternoon, we will have a 45-minute talk, followed by 15 minutes of questions and answers. Exceptionally, for today's talk, comments have been disabled on YouTube, and the live stream will end immediately following the talk before the Q&A session. If you have the link, you may join us for the Q&A on Zoom. To ask a question on Zoom, please use the raise hand feature following the talk. After the Q&A session, professors will be asked to log out. Undergrads, grads, postdocs, as well as other non-faculty in the Zoom session will be invited to the après colloque, a chance to get to know the speaker in a more intimate setting. With that, I will now pass to Eve Lee, chair of the McGill Physics EDI committee, to introduce the speaker. Eve.
Okay, thanks, Bill. We're pleased to have Dr. Tanja Tajmel from Concordia University, where she's an associate professor in the Center for Engineering in Society and Gina Cody School of Engineering and Computer Science. Dr. Tajmel is a distinguished expert and leader in the studies of equity, diversity, and inclusion in science and technology. In 2018, she co-organized the first international symposium on human rights and equality in STEM education at the Academy of the Sciences in Berlin, and she co-authored with UNESCO the Declaration on the Human Rights to Science Education. Furthermore, she is a principal investigator of the project named Decolonizing Light, Tracing and Countering Colonialism in Contemporary Physics, funded by the competitive NFRF Exploration Grant. Dr. Tajmel received her master's in physics and philosophy and bachelor's in meteorology and geophysics from Karl Franzens University Graz in Austria, and she earned her doctorate in didactics of physics at Humboldt University Berlin in Germany. Before joining Concordia in 2018, Dr. Tajmel was a professor at the University of Education Upper Austria. Dr. Tajmel publishes in both German and English, and her new book titled The Human Rights Approach to STEM will be published in spring 2021. So without further ado, please take it away.
Thank you, Eve, for this introduction, and thanks for the invitation to this symposium. It's truly an honor to be here and to discuss with you this important topic, equity, diversity, and inclusion. Let me start with an overview of what I'm going to present today. I'll be talking about EDI as policy, and we'll then go to discuss a little bit of physics and the STEM fields as special case. And then I will take a closer look to diversity, and will then come to normative frameworks. Then I will present equity dimensions, and finally, decolonizing approaches, and I will share with you experiences and the work which I'm doing in the Decolonizing Light project. Now, I'm sure all of you know this kind of website. It's the Canadian Research Council Tri-Agency Statement on Equity, Diversity, and Inclusion. And we know that NSERC and the Canadian Research Council, they pay very specific and particular attention to equity, diversity, and inclusion. Here we have this paragraph. I'm sure you're familiar with that. It's an excerpt from NSERC Discovery Grants description, what should be included in NSERC Discovery Grants applications. And here we also read that when researchers describe the research, training, and development opportunities provided for HQP, they should definitely promote EDI in NSE and EDI in collaborations and so on. So we know all that, and we also know that NSERC is very much committed to EDI. In several NSERC programs, and funding is only granted under the condition that EDI is addressed sufficiently. Now, EDI policies in Canada are grounded in the Canadian legal framework, and I think that's important to keep in mind. It's a rights-based approach to inclusion guided by federal legislation, which includes the Canadian Multiculturalism Act, the Charter of Rights and Freedoms, the Employment Equity Act, the Canadian Human Rights Act. And each of these acts establish principles and values to be included in Canadian society. And a political impetus was given by the UNESCO's 2030 Framework for Action for the Implementation of Sustainable Development Goal number 4, which underlines inclusive and equitable quality education in 2015. This new vision of education is fully captured by Sustainable Development Goal number 4, ensure inclusive and equitable equitable education. And the framework addresses global and national education challenges, and it represents, and that's important, a humanistic vision of education based on human rights and dignity, on social justice. It reaffirms that education is a public good which needs to be accessible to all people. Now, in reaction of this framework for action, universities around the world, and especially also Canadian universities, started to develop EDI strategies and EDI plans. And in Canada, Universities Canada, an organization which represents Canadian post-secondary institutions, has developed 7 inclusive excellence principles, followed by an action plan on equity, diversity, and inclusion. And these inclusion principles are, first, a commitment to diversity and inclusion. We will make our personal commitment to diversity and inclusion. The second principle is we commit our institutions to develop and maintain an equity, diversity, and inclusion action plan. The third principle is we commit to take action to provide equity of access and opportunity. To do so, we will identify and address barriers. The fourth principle, we will work to ensure that candidates from all backgrounds are provided support in their career progress. Fifth principle, we will seek ways to integrate inclusive excellence throughout universities' teaching, research, community engagement, and governments. Sixth principle, we will be guided in our efforts by evidence. So these efforts will be monitored. And seventh principle, Universities Canada will work to generate a greater awareness on the importance of diversity and inclusive excellence throughout Canadian higher education. So this is the reason why all our universities are now embarking on this journey to develop EDI action plans, to develop EDI strategic plans. A recent study conducted by Tamtig and Günther analyzed policies of 15 Canadian universities, and they found that, so they did a content analysis of the different policy documents, and they found that the language in these documents is rather vague. For most universities, equity is an inclusion with a focus on removal institutional barriers to equal access to education. However, fewer universities see equity as redistribution of resources. So, for example, efforts to create preferential hiring approaches or funding designated to equity-seeking groups. And they also found limited evidence on articulating supports of international students with regards to cultural adjustment to addressing social problems. So international students are not recognized in EDI strategic plans and in EDI policies. However, the author said that all universities are now developing very quickly all these EDI strategic plans and EDI policies. In Europe, there is a similar development. The European Universities Association is an association which represents more than 800 universities in 48 European countries. And this association plays a crucial role in the Bologna process and in influencing European policies on higher education. Now, the Bologna process is a process to harmonize European higher education system because, as you might know, all European states had their own educational system, and it was difficult to compare these systems. So the Bologna process, which started in 1999, is a process to find, let's say, to harmonize these systems. And in their report, Claes and Kulik, Jurgensen and Stöber analyzed 159 higher education institutions in 36 European systems. And they tried to find, or they asked the institutions about EDI success factors and indicators for impact assessment. And for example, as top EDI success factor, 76 of the institutions reported a commitment and support of the institutional leadership. So this is by far the most important success factor reported by the institutions. The second factor is direct involvement of the target groups in developing and implementing the strategy and activities. And the third important success factor is involvement of the entire university community. With regards to indicators, so when asked how they are measuring the impact of activities on diversity, equity, and inclusion, 60% said the indicators are the number and the share of students enrolled from less represented and disadvantaged backgrounds. Another indicator is the share and the number of staff from less represented, disadvantaged background. And a third indicator is success stories, role models. And then they also asked on which institutional level EDI is addressed. And the study revealed that EDI policies are rather addressed at a central level than at a departmental level. However, we need to keep in mind that this is a rapidly developing field. So it would be interesting to see how this is in 2 years or in 3 years. But right now, most of the EDI policy is located on central level. Okay, now that was EDI as policy. And now I want to speak about physics as a special case, or the STEM fields as a special case. STEM stands for science, technology, engineering, and mathematics. And I consider STEM fields as a special case for at least 3 reasons. One reason is that physics is considered the hardest science and to be socially independent. Physics has a very specific authority among all other disciplines because it is fundamentally defining scientific key concepts such as energy, matter, force, light, space, and time for all other sciences, and it is the narrative of physics that it is socially independent, that this has nothing to do with society. However, physics is not only the core physical knowledge, it's also a social field. Sociologists know that. Science and technology scientists know that also. So physics is, in the context of EDI, physics has to be seen as a social field with different actors and with different power relations and with different, I would say, processes of inclusion and exclusion. In fact, the narrative of physics as being objective and socially independent even reproduces its authority in the whole landscape of knowledge systems. So this is the first reason, the very special role of physics. The second reason is physics is constructed as masculine. STEM fields are playing a special role in gendering society. For example, Alison Gonsalves, a faculty member of McGill, and colleagues found that the discipline of physics is not only dominated by men, but is also laden with masculine connotations and symbols, and therefore it has been and is still difficult for women to find a place in this discipline. Other studies demonstrate that students who are traditionally underrepresented are also less confident in their own abilities and are less likely to identify themselves as being good. For example, students from weak economic background, from working class students, be it male or women or men, and students from specific groups, ethnic minorities, racialized groups. When we take a look at the bachelor degrees earned by women, this is a figure from American Physical Society, then we see that in the last 50 years, it didn't change a lot in the bachelor degrees. So this is actually representing that physics is still a very male, masculine field, and that most of the physics bachelor degrees are earned by men, about 80%. The third reason, now, so two reasons: physics is a hardest science, physics is a very masculine field, and the third reason why physics is playing a special role, or the STEM fields are playing a special role, is that they are traditionally and historically linked to economy and to power. There are several examples in history which show this linkage between science and economy and power. And there is one very special example, which is the Sputnik shock, an event which took place in 1957, when the Soviet Union launched the first satellite, successfully launched the first satellite. And this, the reaction on this was a shock of the whole Western world. And in reaction to the Sputnik shock, the United States launched support measures and promoting activities for students in STEM. So the STEM fields became important because of, or triggered educational measures after the Sputnik shock, in order to increase the workforce, in order to increase scientists to be winner in this competition, in the race to space. Another example, which happened 43 years later, was the PISA shock. And there are several similarities between the PISA shock and the Sputnik shock. The PISA shock triggered similar promotion activities for science education, which are comparable with the initiatives taken after Sputnik. The difference is that Sputnik occurred as a result of the technological and scientific progress materialized in form of a satellite, whereas PISA, on the other hand, was planned by the OECD, the Organization for Economic and Cultural Development. And the reference point for the OECD were performance targets, and these performance targets were defined by OECD based on what the economies of these countries, of several economic countries, saw important as STEM education. So what they defined as being important in order to have STEM educated students. PISA means Program for International Student Assessment. Now, the interesting thing is that the focus or the goal of STEM education in both examples, in Sputnik and also in PISA, is not really education as a value or as a goal in itself, but it is as an education, STEM education, for reasons of competitiveness, for reasons of employability, for reasons of usability. So somebody is defining these goals. Now, there is one metaphor which is very much related to these kinds of orientation, or this picture or this view of STEM, this approach to STEM education. It is the leaky pipeline metaphor. I'm sure you heard about that. What is the leaky pipeline metaphor? What does it say? It says that there are diverse students, and these diverse students are entering the STEM pipeline, and at certain points they are leaking out. They are leaving the pipeline. They are dropping out. They are dropping out, and in the end, there are only a few students. Now, the interesting thing is, and that is why this is related to equity and diversity and inclusion. The group that is successfully passing the pipeline is not as diverse as the group that is entering the pipeline. Would the group at the end be of the same diversity? Would it be a representation of the diversity? There wouldn't be a problem. Not everybody needs to become a scientist or a physicist, but the group at the end is much more homogeneous. The reaction of most of the educational systems is to fix the leaks, right? To fix the leaks so that nobody can drop out, that nobody can leave the pipeline. What remains unconsidered is the pipeline itself, right? The pipeline is not really questions, but we are fixing the leaks by measures like raising students' interest in STEM, whatever. Let me make this more explicit with this picture. I call this approach to diversity the essentialist approach to diversity because it is dealing with students as if diversity was their characteristics, as if it's an attribute of students. And these students are now distributed through PISA assessment or whatever on different fields, on different levels of performance. We have the high performers and we have the low performers. And the low performers are the problem for economy, right? Because they do not have the skills that are required by economy. Another example in this context, in the context of employability or usability of science education, because we are very much used to this notion of usability and employability. But for example, let's think about astronomy. In some countries, astronomy is no longer part of the science curriculum in schools. Why? Because it is not considered to be important for employability. So I think it's really important also for science education to think very well about the goals. Who is setting the goals? Why we should have a certain kind of science education. So the efforts that are taken are fixing the leaks by compensatory measures. I already mentioned this is more or less symptom therapy. And I also mentioned in this context raising the interest of students or having girls' camps, having summer camps, and so on. These are all important and nice measures. However, we should not expect that this is enough because these measures are not targeting the roots of underrepresentation and the roots of social inequity. An example, also Donald Trump promoted science for girls and for diverse students, for Black students, and also Ivanka Trump. But we will probably agree that reducing social inequity is not necessarily on Trump's political agenda. So now I think we should also talk about critique of EDI because it is directly related to this critique of not dealing with the roots of social inequity, but only dealing with diversity on in a superficial manner. There is critique of EDI from different perspectives, but there are certain perspectives which I think are more important to be taken into consideration than other perspectives. And this is especially critique which is coming from groups that are actually target groups of our EDI efforts. Black groups, Black scholars, Black students, Indigenous scholars, Indigenous students. These are actually target groups of EDI efforts, and when they are criticizing EDI, then we need to take it very seriously. And one critique is, for example, EDI is just used as a buzzword to get funding. Unfortunately, that might be true in many cases. EDI is centering whiteness and serving white interests. Well, when we take a look back to Donald Trump, then yeah, maybe this might also be true. And EDI is whitewashing of social inequity. Now, the challenge is now we need to respond. EDI needs to respond. How does EDI respond to social equity or social inequity? How does EDI respond to decolonizing academia? Because this is also something that is currently going on, and it's also a rights-based approach. And is there a robust and consistent normative framework for this? I think in order to discuss that, we need to take a closer look at, on diversity. What actually does diversity mean? When we speak about diversity and celebrating diversity, appreciating that diversity, then we often see diversity as a general characteristics as individuals are different. All individuals are different, and we should appreciate and celebrate and respect that. That is a very nice, a very positive approach to diversity. However, it is not necessarily a social equity approach to diversity, because from the social equity perspective, diversity is social difference and inherently connected to inequity and to certain privileges. So, for example, when we see diversity through the lens of social inequity, then we have different lines of difference or categories of difference. The classical ones are gender, race, and class. And these different categories of difference are structuring society. And we have the privileged group and we have the oppressed group. These lines of difference are intersecting, which means they are there emerge specific vulnerable situations for individuals depending on the intersection of categories, depending on their position in these intersecting categories. And there are many more axes of difference. We see them here, the intersecting axis of privilege, domination, and oppression. And here, for example, we see able-bodied, ableism. Here we have able-bodied and as oppressed group persons with disabilities, or upper and upper middle class. This would be classism, and on the other end, working class and poor, or English as second language as oppressed group, and English Anglophones as a dominant group of privileged groups, language bias, or here racism, white, and people of color. And there are many more intersecting axes of privilege. Now, the difference between this picture and the other picture of diversity is that in this context, or from this perspective, diversity is always discussed as in the context of privileges. What does NSERC say to diversity? This is an example, an excerpt from the guide for applicants considering equity, diversity, and inclusion in your application. And I really can recommend this guide because it's they give a very good overview of the terms. I mean, of course, I would recommend to read more about these terms, but it's a very good and very condensed overview. And here they say, recognizing and valuing diversity must be accompanied by concerted efforts to ensure inclusion of diverse populations, meaning that individuals are and feel valued, respected, and equally supported. So not only feel, but also are valued, respected, and equally supported. That is very important. I think when reading these guidelines, as they are very short, we need to read every word of them. The next excerpt is about intersectionality. What is NSERC saying about intersectionality? Rather, intersectionality recognizes that inequities are never the result of single distinct factors. Rather, they are the outcome of intersections of different social locations, power relations, and experiences. So NSERC is explicitly speaking about power relations, and right so, because only like that EDI will address social inequity. And the third excerpt is about equality. Equality means, it does not, I start here. It does not mean that people have to become the same, but that their rights and responsibilities and opportunities do not depend on their identity. Their rights, responsibilities, and opportunities do not depend on their identity, which means NSERC reinforces here that different people are equal, at least in one sense, because they have the same rights. And this is actually the approach of the human rights as well. So this needs to be elaborated a little bit more. And therefore, I'm now going to the normative framework and to the human rights. The Universal Declaration of the Rights of the Human Rights. The right to education is important for us as secondary educational institutions and for all other educational institutions. And the right to education is enshrined in the Universal Declaration of Human Rights. This means that the right to education builds on a broad and consistent international agreement. What do the rights say? The right to education is an empowerment right. It addresses primary, secondary, and higher education. It is the right to non-discriminatory access to education, and it cannot be transferred or renounced. And the right is valid regardless of economic exploitation. So back to astronomy, yes or no, astronomy and science education. Well, economic exploitation is not a reason to not educate somebody. Now, the human rights are a very consistent and robust framework because they build on a broad international consensus. 171 state parties ratified the right to education, which means they implemented it in their legislative systems. 4 members are still in signatory status, and 22 members didn't take any action with regards to the right to education. But we see this broad international consensus. Another document or another declaration which is important, especially for our context, for the Canadian context, is the Declaration on the Rights of Indigenous Peoples, which is from 2007. And in Article 14 of the Rights of Indigenous Peoples, it says, Indigenous individuals, and particularly children, have the right to all levels and forms of education of the state without discrimination. All levels without discrimination. This includes universities. And in Article 15, it says, Indigenous peoples have the right to the dignity and diversity of their cultures, traditions, histories, and aspirations, which shall be appropriately reflected in education and public information. So this is the reason, this is the rights-based approach to decolonizing or to indigenizing and decolonizing academia and curricula. I'm not going to talk more about indigenizing or decolonizing. There is a difference, and I don't want to mix that up, but just to say this is the legal background. Now, the rights to education, or the right to education, is we can say that it is implemented, or it is included in the right to science education is included in the right to education, however, not explicitly. And therefore, in 2018, I had the honor to be part of a group of scholars and representatives from UNESCO to develop the Declaration on the Right to Science Education, to make explicit that science education is an important part of education. And the declaration is based on the notion of science as a common good, that science education must be accessible and acceptable for learners. And acceptability, so accessible means it needs to be accessible physically, but also economically. And acceptability means it includes that the content of science does not reproduce discrimination, social power relations, and stereotypes. So with this declaration and with this formulation of the declaration, we wanted to explicitly address the content of science education and the content of science, as this is also contributing to certain reinforcement or even production of social power relations. Now, from this rights perspective, we now have a different picture, or we need to correct this picture, because we are speaking of the individuals, and all individuals have the right to education, the right to STEM, right to the access to STEM, and therefore we need to start with one step before, with the human beings. And the human beings are equal in the sense that they all are human beings, and as human beings they all have the right. But now happens what we call intersectional, multi-level discrimination, selection, exclusion processes. There are happening social processes, intersectional processes on different levels, on levels of identity construction, on levels of representation, cultural representation, and on structural level. And through these processes, individuals become different. So these are actually difference producing or difference generating processes. And in the end, we see this picture, the disparities. And we can say disparities in performance in STEM, but we can also say social inequity, because this is just a picture for social inequity. And from this perspective, we are not speaking about disparities in performance, because we are rather talking about access. These students or these people have access to STEM, and these people do not have access to STEM. So we do not have the disparities in performance, but the disparities in access to STEM. The importance to have this picture in mind is that the focus of research is now not the student and the differences of the students. The focus is here, the exclusion mechanisms, the processes that produce difference. And for STEM and also for physics, here is physics. So we are all who are here now are in this group, and all the others are not here, right? And for these processes, it's interesting and important to study how STEM fields contribute to this kind of difference making. Now we need to reconstruct exclusion processes that happen in the STEM fields. And what can we now do as researchers or as teachers in the social position that we have? We can follow EDI, but I would suggest to rather speak of equity dimensions instead of only equity, because this is structuring this can be helpful to structure our efforts. Equity, as we have seen, is much too complex. There are these intersecting processes that are going on, and therefore it might be helpful to speak about equity dimensions. The first equity dimension I suggest is actors' equity, who we are. This dimension addresses the representation of diverse identities, the recruitment of members from underrepresented groups, from marginalized groups, and the composition of research teams. Actors' equity entails equal access to academic careers, diverse people doing science, diverse people being cited, and citing researchers from the global south as well, right? Because equity and social equity does not, or equity considerations do not stop at the borders of Canada. Social equity is always a global phenomenon, and social inequity as well. So actors' equity is basically maybe that what we understood as equity or EDI, because when we were focusing on the diversity of actors. The second dimension is content equity, what we produce. This dimension addresses the critical assessment of scientific knowledge and the practices of knowledge production. And it recalls the notion of acceptability of science in line with the right to science education, knowledge that reinforces and reproduces bias and social power relations is not considered to be acceptable. So this dimension, content equity, would also call for the representation of diverse knowledges, for example, indigenous knowledges in academia and in science. The third dimension is outcome equity, whom we serve. This dimension addresses the question of who benefits from our scientific research. This includes the consideration of global and local impact of research, as well as sustainability versus marketability considerations. And the fourth dimension is input equity, what we teach. This dimension focuses on the diversity of knowledges and critical aspects being part of the STEM curriculum, because it is probably not acceptable for students who are oppressed by colonialism, by racism, that colonialism and racism is not mentioned at all in science, because science played an important role in this regard. So these are the four equity dimensions, and now I have 4 minutes left. I think I will go and give you some examples. In we are currently doing textbook studies, and because textbooks are a very good representation of science and scientific knowledge. And what we are doing is for example, we are studying textbooks, the images of textbooks, and also the text of textbooks. And for the images, we are coding all people who are depicted in a textbook. And I will present you the results of undergraduate physics textbooks, people, or how individuals are represented gender-wise. So with regards to category gender, racialization, and role and activity. We distinguished between Black and other people of color, because we found that people of color is a too broad category, and Black people are a distinguished category in the context of racism and racialization. And with regard to role and activity, we identified the depicted individuals as scientists or performing a scientific activity, as historical scientists, famous scientists, non-identifiable, or being depicted in an activity which is not really identifiable, and as athletes. Why athletes? Because athletes are commonly used to illustrate mechanics or to illustrate physical concepts. What did we find? These are 267 images, and we found in the undergraduate physics textbooks that there are very few people represented as performing a scientific activity. Very few. There are more people presented as famous scientists. In fact, five times more than women. There are only white people presented as performing a scientific activity and presented as scientists, as famous scientists. There are Black and people of color and white people presented as athletes. And there are a lot of overrepresented Black and people of color in the field of non-identifiable activities. Now, these results are very interesting because obviously the textbook tries to include diversity of skin color, but the overrepresentation of people of color in the field of non-identifiable activities, while not being represented as doing a scientific activity or being a famous scientist, even reinforces science as a white field. How do the people look like? For example, these are examples from OpenStax Physics Volume 1. These are the famous scientists. We find them probably in all textbooks. And these are the other depictions people are depicted as dummies, right, as figures, just to demonstrate physical laws or physical contexts. Now let's take a look at the text in physics textbooks. When we look up the word woman in these physics textbooks, then we find it on 984 pages 14 times. And I'm just showing you two examples where this word woman is mentioned in two text examples. A woman was transporting an open box of cupcakes to a school party. The car in front of her stopped suddenly. She applied her brakes immediately. She was wearing her seatbelt and suffered no physical harm. But the cupcakes flew into the dashboard and became smash cakes. Explain what happens. So here, the woman is contextualized with cupcakes, which she is delivering to a school party. From a gender perspective, this would be a reinforcement of gender roles. It would actually support the masculinity or the femininity of household and the masculinity of physics, because no other woman is mentioned in the context of physics. Another example: what is the density of a woman who floats in fresh water with 4% of her volume above the surface? This could be measured by placing her in a tank with marks on the side to measure how much water she displaces when floating and when held underwater. What percent of her volume is above the surface when she floats in seawater? Now, this is a really interesting example. That can be discussed from different perspectives, but it definitely should be discussed with regard to acceptability. Is it acceptable for women who are teaching or who are studying this textbook? There will be some laughs in the classroom and so on. So this is the first question, what needs to be answered. And the second question is, or not the question, it's actually a statement: a woman is not a physical category, a woman is a social category. There is no density of a woman. So these are examples. The textbook is from 2018, and I'm looking forward to do more of this textbook content analytical research, because this is really very interesting. Now I will skip these slides, and yeah. And I just maybe 5 words to the project New Frontiers in Research funded project Decolonizing Light Tracing and Countering Colonialism in Contemporary Physics. I just want to mention that we are very happy that we were successful in this project. We are collaborating across disciplines internationally, across disciplines of physics, first people studies, sociology, science and technology studies, engineering. These are some collaborators, students and researchers who are involved in this project. And we are also collaborating with the Kanawaka Environmental Protection Center. And with this center, we are doing a citizen science project. I'm jumping a citizen science project about air quality measurement in Kanawaka, because Kanawaka is definitely influenced by traffic, road traffic, air traffic, and marine traffic, because here we see the Atlantic Ocean, here we see Montreal, here is Kanawaka, and this is the marine traffic yesterday, 2 p.m. So these vessels passed Montreal, and all these vessels passed Kanawaka, and therefore we are doing this air quality project with Kanawaka. It's a citizen-driven project. The community members are trained to build and operate their own devices. The project is supported by schools and communities. And if you want to know more about that, I'm happy to tell you more about that. And if you're interested in more details about how the air quality is measured, I'm happy to connect you with Gregor Kos, who is leading this sub-project. And that's it. Thank you very much for your attention.
Thank you very much, Professor Tajmel, for a very nice and interesting talk. If you also appreciated the talk, please let Professor Tajmel know in the chat in Zoom if you're in the Zoom session, and I will pass the Zoom chat on to Professor Tajmel at the end of the talk so that she can see all of the good things that you've written about the talk. And that concludes the talk portion of the Physical Society Colloquium. Before we end the live stream for the Zoom Q&A, I would just remind everyone to please join us for next week's Robert E. Bell lecture, which will be given by Professor Leonard Susskind from Stanford. His talk is entitled Gravity and Quantum Mechanics Seen Through a Holographic Lens. Thanks once again to all who have joined us. If you're on the Zoom session, please stick around for the Q&A and après colloque. To those watching on YouTube, have a good evening. Bonne soirée.